Welcome. We will start the subnetting 2. At first, we'll solve some problem from the subnetting. The question is an IP network 192.168.130.0 is using the subnetting marks 255.255.255.224. Determine number 1, the number of subnet, number 2, number of host in each subnet, and the third question, what subnet the following host belongs to: 192.168.130.10, 192.168.130.93, 192.168.130.220, 192.168.130.250. So the given IP address 192.168.130.0, that is belongs to the class C address. So the by default subnet marks of class C is 255.255.255.0, that is /24. Given subnet marks is 255.255.255.224. So the binary of the first by default subnet is this first octet is 80, and this is the binary representation of the subnet marks. All are represented in the binary forms. Now find this all ones, that is the network bit, and this is the total 24 bits, and all zeros that represent the host bits, and it is the 8 bit. So the in class C the last 8 bits are host bits, but the subnet marks that is given here, the total number of 1 is 27 bits, that is represent the network bit, and all zeros, that is the last 5 bits, this represents the host bit. So our first question was determine total number of subnets. So here this extra one, these 3 ones, 3 bits will be represent for representing the extra subnets. So that will be the 2 to the power 3, that is 8 subnets. So there will be total 8 subnets. Now the whole block, that is the first address, that is from 0 to the last address, will be 255, that is here the total host will be 256. This total 256 host will be divided into 8 subnets. That's mean class C 1 address is divided into 8 subnets. This is subnet 1, subnet 2, subnet 3, subnet 4, subnet 5, subnet 6, subnet 7, subnet 8. The total network will be divided into the next question, the total number of address in each subnet, that is the total host divided by total subnet. Total host is 256 divided by 8, that is 32. In each subnet there will be total 32 hosts. In the first subnet, this is the first address, and the first address of the second subnet will be 192.168.130.32, and the first address of the third subnet will be 192.168.130.64. That is the first address of first subnet 32 plus 32 64, and this is the first address of the fourth subnet. This is the first address of the fifth subnet. This is the first address of the sixth subnet. This is the first address of the 7th subnet, and this is the first address of the 8th subnet. Now the third question is, what subnet the following host belongs to? There are given 4 different addresses. You have to find out in which subnet this address belongs to. Look at the first address. The last octet is 10 and it belongs to the subnet 1, and the second address, the last octet is 93. If we check the address of the each subnet, then it belongs to the subnet 3. The third address, the last octet is 220, that belongs to the subnet 4, and the last address, the last octet is 250, that should belong to the subnet 5. This is the solution of the problem. So the next assignment will be, a network is with subnet marks of 255.255.255.254. Determine maximum number of hosts in the network. What is the broadcast address of the networks? Next assignment. An organization granted the block 211.17.189.124. The administrator want to create 32 subnets. Number 1, find the subnet marks. Number 2, find the number of addresses in each subnet. Number 3, find the first and last address in the first subnet. Number 4, find the first and last address in the last subnet. Thank you.